Okay, in this exercise we're going to calculate the length of several curves, and we'll begin with the first one, which is the catenary. The catenary is, this the wires for the electric trains, right? Between posts, right? There are wires. Okay, the curve described by these wires is a catenary, right? And the shape of the catenary is given by this function here, which, by the way, is nothing but the 2 times the hyperbolic cosine of x half. Okay, so this is what the catenary looks like if you plot it. Here's the catenary, right? So it's got this shape. Let me put it like this. Okay, so it's got more or less this shape, right? We're interested in the interval 0 to 2, right? So we're going to calculate the length of this bit of the catenary here. Okay, right. So the way to do this is we need to find a parameterization of the catenary, but given that you have y as a function of x, the parameterization of the catenary is very easy in terms of x, right? Is x and 2 times the hyperbolic cosine of x half, right? That's the parameterization, and x runs from 0 to 2. And we want to calculate what is the length of this curve in this interval here. All right, the formula for this is, remember, is the integral in the parameter of the length of the derivative with respect to the parameter of the parameterization. Okay, this is the general formula. So in our case, the derivative of this with respect to the parameter is equal to 1, and the hyperbolic sign of x half. Okay, this is the hyperbolic sign multiplied by 1/2 and by 2, so they compensate, and then you have this. So the length of this of x is equal to the square root of 1 square plus the hyperbolic sign square. Hyperbolic sign square of x half. Okay, 1 plus the hyperbolic sign square is the square of the hyperbolic cosine, and the square root makes this the hyperbolic cosine of x half. So this function is just this, and then the length that we want to calculate is the integral from 0 to 2 of the hyperbolic cosine of x half. This is straightforward, right? There's an immediate primitive of this. This is 2 times the hyperbolic sign of x half between 0 and 2. Hyperbolic sign at 0 is 0, so what we have is 2 times the hyperbolic sign of 1, which is, this number is just minus e to minus 1. All right, so that's the length of the catenary.